In this video, we're looking at compound interest and depreciation. So, a repeated product or multiplication can be written and calculated using a power. So, what this means is if I have something such as 1.06 times 1.06 times 1.06 again times 1.06, instead of writing it like that, which takes time, which we don't want to spend too much on, I could rewrite the whole thing as 1.06 to the power of 4, because there's 4 of them. Alright, there's 1, 2, 3, 4. And the same thing goes for another number such as 0.85, for example. If I go 0.85 times 0.85, I could just rewrite that as 0.85 to the power of 2, because there's 2 of them. Now, this concept is used when we're trying to calculate compound interest. Now, compound interest is the interest which is added to an investment, such as your bank account, your savings, before the next amount of interest is calculated. All right. Now, it's important to note, sometimes you'll see something such as P.A. All right, or PA after a percentage. Now, this is known as per annum, or if you just want to talk in simpler terms, it just means per year. It's the interest rate every year. Okay? So, we're going to use this concept that we just talked about, this multiplication repeated product concept, to find the total value of an investment over time. So, in our example here, we have the total value of an investment is 8,000. We're going to invest that at 5% per annum. Remember, that just is per year, for 4 years. We want to find what this value is after those 4 years. So the first thing you want to do is you want to find our percentage that we're increasing by. So we want to find the percentage increase. Okay? So we know it's going up, so we're already staying at 100%. We know we've got 100% there because that's what it is. That would just keep it the same price. Now, it told us in the question up here, it's going up 5% per year. So that's our 100% plus an extra 5% every year. So we end up with a 105% increase. Now, we don't want to deal with percentages. Sometimes they can get tricky and messy. We want to deal with decimals. So we need to convert it to decimals, all right? So our next step will be convert to a decimal. All right? Now that's really easy. You just divide it by 100. Or, how I like to do it, if we have 105%, this is going to equal 1.05 as a decimal. All right? You just put a dot after the 1. Okay? The next thing we want to do is we want to multiply this by the investment. So we'd have 8,000 times 1.05. Now that's 1 year. Here's our second year, our third year, and our fourth year. But let's not worry about that. I don't want to write all that or put that in the calculator. So I'm going to be lazy. And what I'm going to do is just go 8,000 times 1.05 to the power of 4. Alright, because it's 4 years to the power of 4. So that's the trick going forward. Instead of writing them all out so many times, your power is just how many years you're investing for. You put that in the calculator and you end up with 9,724.05. Okay? So again, what we did is you find the percentage increase, you convert it to a decimal, and then you multiply it by the investment as well as how many years there are. Now that's your power. Okay, so next one, finding the initial amount. So what happens if we know that we're investing for 6 years, and at the end of the 6 years we have 62,150. We know the interest rate was 9%. We need to know how much was invested at the very beginning. So we're going to start off in the kind of the exact same way. I want to find that percentage increase first. And I know that, again, it's our 100% plus how much percentage is going up each year. So we know it's 109%, which is 1.09. Okay? Now, before, we kind of had a mini formula going on there. We knew that our investment was equal to the initial amount that we put in. It was multiplied by that rate that we just have above. And up here we had time. All right, that was the time. So, well, we can use this now to find our initial amount. We know our investment, how much we put in, was 62,150. We're trying to find our initial amount. I'm just going to put X for now. And we're going to multiply by the rate, which we said was 1.09. And we know it was invested for 6 years, so time can change to 6. Now I've got something, an algebra formula, that I can just rearrange to get an answer. So what I'm going to do, like any algebra thing, remember we do opposites. I want the x by itself, so I'm going to do the opposite of this over here. I'm going to divide by that, which means I also need to do it over here. So what ends up happening is these cancel out, and I'm left with 62,150 $sign over 1.09 to the power of 6 will equal x. Now if I go and put that in the calculator, x is now going to equal $37,058. Now sometimes you'll see that we're not actually increasing, we're decreasing. It has a special name and it's called depreciation. Now depreciation is the reverse situation. It's where we're going down. So usually this happens to cars as a good example. So you have a car that's worth $3,000. It depreciates by 15% every year. What's its worth at the end of the 5 years? So we kind of do the same thing. All right. So we're going to find our percentage decrease. All right. So we know, again, we always start at 100 and it's going down 15%. So I'm at 0.85. Sorry, I skipped a step there. We're at 85%, but I want it in decimals, so 0.85. All we did there was divide by 100. Okay, now remember we had our formula before, so that end value or investment is going to be the original, the initial amount times the rate to the power of time. Okay, so our original amount was 3,000. We know that rate we found was 0.85, and it's after 5 years, so 5 goes up there. Put that in the calculator. You end up with 1,331.12.